Hi, a very good afternoon to everyone. We are from Group 3. Today, me, Aliana Jiha, together with my group members Nur Izazi, Muhammad Ami Hamzah, Eng Yidin, and Shamira will be presenting questions from Tutorial 10.
Hello everyone, Assalamu alaikum and good day to you all. I am Muhammad Amir Hamza Khan Polo. Now I'm going to start the question on 1, and the question is, according to an estimate, the average earning of female workers who are not union members are $300 per week, and those of female workers who are union members are $505 per week. Suppose that these average earnings are calculated based on random samples of 1500 female workers who are not union members and 2000 female workers who are union members. Further, assume that the standard deviations for the two personnel population are $30 and $35 respectively. We need to test at the 2.5% single level whether the mean weekly earnings of female workers who are not union members are less than those of female workers who are union members. So at first, here it's given those who are not union members, mu1 equal to be 380, n1 sample n1 equal to 1500, and sigma 1 standard deviation is going to be 30. And those who are union members, for them mu2 going to be 505, n2 going to be 2000, and standard deviation 1 is sigma 1 is going to be 35. So the two hypotheses are H0, hypothesis 0 is going to be mu1 not greater than equal to mu2, and hypothesis 1 is going to be mu1 smaller than mu1 smaller than mu2, and alpha equal to 0.025 and z alpha equal to minus 1.96, which we will find from the normal standard deviation, normal standard distribution table. And moving to the next slide, we will reject hypothesis 0 if z is smaller than z alpha and z equal to mu1 minus mu2 root over sigma 1 square plus divided by n1 plus sigma 2 square divided by n2, that is 388 minus 505 divided by root over 30 square by 1500 by putting the value from the given, and plus 35 square divided by 2000. So we will get minus 106.25. Now we can see that z is going to be minus 1.06.25, which is smaller than z alpha, that is minus 1.96. So hypothesis 0 is rejected, and you can also see in the table like false on the left side, where area of the shaded region hypothesis 0, and that is going to be rejected, and z alpha equal to here is minus 1.96. So therefore at 2.5% single level there is sufficient evidence to show that not union members have less weekly earnings than union members. Now I am passing the presentation spot to my next speaker. Thanks everyone, thanks to all.
So hi everyone, I'm Eden and I will continue question 2. A sample of 16 children from New York State showed that the mean time they spend watching television is 28.5 hours per week with a standard deviation of 4 hours. Another sample of 13 children from California showed that the mean time they spend by them watching television is 23.25 hours per week with a standard deviation of 5 hours. Using a 2.5% significance level, can we conclude that the mean time we spend watching television by children in New York is greater than that for children in California? Assume that the standard deviations for two populations are equal. So based on question 2, we will know that sample size and mean, also standard deviation S. So we assume New York is 1 and California is 2. N1 equal to 16, U1 mean 1 equal to 28.50 and S1 equal to 4. N2 equal to 13, mean 2 equal to 23.25 and S2 equal to 5. We go step by step. Step 1, we will know null and alternative hypothesis, where null hypothesis H0 is U1 is lesser than or equal to U2, and H1 or alternative hypothesis is U1 larger than U2. Step 2, level of significance, we will know that it's 0.025 because the sample size is lesser than 30, so we use pool T test. Step 3, we reject null hypothesis or H0 if test statistic value is more than upper bound critical value. Otherwise, do not reject H0. So step 4, we will know that the degree of freedom is actually N1 plus N2 minus 2 equal to 16, and is equal to 13 minus 2 equal to 27. So since level of significance is 0.025, the critical Z value will be 2.052. Going to the next step, which is step 5, we have to find pool variance, where the formula is in bracket N1 minus 1 times variance 1 plus in bracket N2 minus 1 times variance 2 over N1 plus N2 minus 2. We sub the numbers inside and the final answer will be 20, and 20 will be our pool variance. For step 6, we have to find T statistic, where T formula is population mean 1 minus population mean 2 over square root pool variance in bracket 1 over N1 plus 1 over N2. We sub the numbers inside and we will get 3.1440. Going to the next step, which is step 7. Now we know that T statistic is equal to 3.1440, which is larger than 2.052. So the test statistic is in the rejection region. In conclusion, there is still sufficient evidence that children in New York State spend more time on average watching TV than children in California. That's for the answers for question 2. I would like to pass the time to my mate.
Okay, hi, for question 3. At the 5% significance level, can you conclude that the blood pressures before and after the completion of the dietary plan is different? So, based on the table, we have before and after, right? So first, we need to calculate the difference, before minus after, and then from the answer, we can calculate the difference mean. To calculate the difference mean, we need to sum up all of the differences, which we will get 35, and divide by 7 because we are currently observing 7 adults. So, second, we need to find the standard deviation. How to find the standard deviation is, in a bracket, you need to subtract the difference and the mean, and then square the answer for each adult. I'll show you the formula and step in the next slide. Okay, here, first you need to state the null and alternative hypothesis. So in the question, the one is to conclude that before and after the completion of the dietary plan is different, which means that will be our alternative hypothesis, because we need to do an experiment and observe on those. So our alternative hypothesis will be the mean difference will not equal to 0, and it will be the opposite for null hypothesis, which is the mean difference will equal to 0. Next step, we need to find the T statistic to determine whether we want to accept or reject the null hypothesis. So since our hypothesis is equal sign, our graph will be a two-tailed test. We need to divide our significance level by 2. So in the question, our significance level is 0.05, and divide by 2, we will get 0.025. Next, we need to find the degrees of freedom, which is n minus 1. Our n is 7, so 7 minus 1 is equal to 6. As you can see from the statistic table that I included here, we'll get our T statistic is 2.447. We will reject the null hypothesis if our test statistic value is greater than 2.447. So the next step we need to find the critical value of t using the formula that I've put in the slide. So mean divide by the standard error. You just need to fill in the value because we already calculate the value in the previous slide. The answer we will get is 1.226, which is the critical value is lesser than 2.447, right? So to conclude, the decision is to not reject the null hypothesis. We failed to conclude that the blood pressure is different. Thank you.
Hi, my name is Shamira Agratusna and now I will be explaining about question number 4. The Lottery Commissioner's Office instead wanted to find if the percentages of men and women who play lottery often are different. A sample of 500 men taken by the Commissioner's Office showed that 160 of them play the lottery often. Another sample of 300 women showed that 66 of them play the lottery often. Testing at the 1% significant level, can you conclude that the proportion of all men and women who play the lottery often are different? From this question, we can conclude that this is two sample tests of proportion. How we can solve these questions? Firstly, you have to state the null and alternate the hypothesis. The keyword is that there is a difference, so our hypothesis will be have difference or no difference. Since the sample size are relatively large, we have to use the normal distribution. And for the significant level, we're gonna get 0.01 and the critical value of z are negative 2.58 and positive 2.58. Then we have to calculate the proportion of each sample, which is we have to let P1 be the proportions of men who play the lottery often and P2 is the proportions of women who play the lottery often. And for the proportions of sample P1, to get the proportions we have to divide 160 with 500, we're gonna get 0.32, and for the P2 we're gonna have to divide 66 with 300 and then we're gonna get 0.22. After that, we have to put the proportions using the formula given. We have to substitute all the value given by the questions into that formula, which is 160 plus 66 divide 500 plus 300, we're gonna get 0.2826. After we calculate all the values, we have to combine it and transfer it into the Z formula. After we substitute all the numbers in the Z formula, we're gonna get 3.041. As we can see, 3.041 are larger than 2.58, and it is in the rejection area. Therefore, we have to reject the hypothesis, and the answer is the proportions are often different.
That is all from us. Thank you.